We're surrounded by concrete pretty much everywhere we go. But let's be honest, we don't really notice it until something goes wrong. And when it fails, the culprit is often some kind of hidden enemy, a defect that was baked in right from the start. So today, we're going to pull back the curtain and uncover what those hidden enemies are. It's so easy to look at a little crack on a concrete wall and just think, it's just wear and tear. But you know what? That is a huge mistake. More often than not, that tiny little flaw you see on the surface, it's just the tip of the iceberg. It's a warning sign that something much, much more serious is going on deep inside. And this is the part you really got to get. This isn't just about things looking pretty. No, every single one of these defects, I don't care how small it works, is a weak link in the chain. It actively reduces the concrete's strength, it shortens its lifespan, and yeah, it puts the whole structure at risk. Okay, so how do we actually spot these weak links before they turn into a full-blown disaster? Well, let's dive in and start with the usual suspects, the most common defects you're going to come across. First on our list is something called honeycomb. And yeah, you can see exactly why they call it that, right? It leaves this rocky, almost pockmarked surface. So what's happening here? It's basically when the cement paste, the glue of the concrete, doesn't get all the way into the gaps between the bigger stones, the aggregate. And what you're left with are these empty pockets or voids. Next up, we have segregation. Now, think about it like this. Concrete is kind of like cake batter, right? All the ingredients have to stay perfectly mixed together. But if they start to separate, the heavy stones sink to the bottom and the lighter cement paste floats to the top, you end up with a really weak, inconsistent mess. That right there is segregation. Now, bleeding is actually a specific kind of segregation, and it's one of the easiest to spot. You've probably seen it. It's that layer of water that pools up on the surface of freshly poured concrete. Now, a tiny bit of this is totally normal, but when you see a lot of bleeding, that's a problem. It means too much water is coming out of the mix, and when that water evaporates, it leaves behind a really weak and porous top layer. And guess what happens to that weak top layer we just talked about? Well, whether it's because of bleeding or from something like the stress of freeze-thaw cycles, you can get what's called surface scaling. This is literally when the top surface starts to flake and peel away. It looks awful, for sure, but worse than that, it exposes the concrete underneath to even more damage. All right, so spotting these defects is one thing. That's step one. But if we really want to prevent them, we have to dig deeper and understand why they're happening in the first place. So let's shift gears from the what to the why. And what's so interesting is that when you trace it back, it almost always comes down to a failure somewhere in the process. We're talking about three main culprits here: poor workmanship, using the wrong mix, or not vibrating it correctly. Just about every defect we've looked at can be traced back to one of those three things. Let's take vibration, for example. It's the perfect showcase of how important technique is. When you do it right, it's magical. It consolidates the concrete, gets rid of trapped air, and makes it super strong. But if you do it too much, or maybe not enough, you can actually cause the very problems you're trying to fix, like segregation. It's a total double-edged sword. And of course, good technique is often the first thing to go when you're under pressure. When a job site is rushed or when there's not enough supervision, people start cutting corners. Maybe they don't vibrate the concrete long enough, or they add extra water to the mix to make it flow easier. And those shortcuts lead directly to the defects we've been talking about. The people and the process, they are absolutely huge factors. So you can really see the chain reaction here, can't you? One mistake, let's say an incorrect mix, doesn't just stop there. Nope, it leads directly to things like bleeding and scaling. And in the end, you've got a structure that just isn't going to last as long. And look at poor workmanship. It's like the one root cause that can lead to literally any of these problems. Okay, so we've diagnosed the problem, we've figured out the root causes, so what's the cure? Well, the good news is this stuff is totally preventable. So let's talk about how to get it right and build with integrity from day one. So what's the big secret to preventing all this? Honestly, it's not some fancy high-tech gadget. The single most effective thing you can do is just have good site control. That's it. It all boils down to discipline, managing the process, the materials, and the people every step of the way. And, being on top of things on site doesn't just give you a better product. It saves a ton of money. Think about it. Catching a problem with the mix before you pour is so much cheaper than having to come back and fix a major structural flaw years later. It's not even close. So, what does good site control actually look like in practice? Well, it means having checkpoints at every single stage. You're verifying the mix design is right before a single drop is poured. You're supervising the placement so nobody's rushing. You're making damn sure the crews are properly trained, especially for something as crucial as vibration. And then you're inspecting the work at every step. It's all about being proactive, not reactive. And that, right there, is really the key takeaway from all of this. A concrete structure is only ever as strong as the process you use to build it. We spend so much time and energy worrying about making the concrete itself last, but maybe the real question we should be asking is this: is your site control built to last too? Definitely something to think about.